Welcome back to RandomRodShop, folks. Well, today we're going to talk about AI. It's been a few weeks since I actually made a video on our old hot rods. I've been tied up short on a quilt machine. My aunt gave my wife a quilt machine, and it's from the 2005-2010 time frame somewhere. It was right at the start of the computerized quilting machines, and this company was one of the first ones that actually put one together. It's a PC quilter, and so they used a Windows XP computer. They had software that they had wrote. It had the robotics were made in Oregon, and the XY table was made in, I think, Indiana. Anyway, the quilt frame itself was homemade, and I don't know which one of the groups made that, but it's sort of like a RandomRodShop quilting machine, kind of parts from everywhere. Anyway, my lovely brides wanted a quilt machine, so I'm like, okay, well, let's get it out and let's see what we can do. My first pass was to try to get it running as it was, and eventually I did get it operating off the Windows XP computer. It wasn't happy. The software was all out of date, and the battery on the XP computer had died, and so it went back to default status. Anyway, it corrupted all the software, and I'm like, fine. Fine. So I took all of that stuff off and said, well, let's see if we can find a stitch regulator. This is an old machine, and they had kind of redneck engineered this thing. It's a handy quilter, 16-inch long arm. Well, I guess mid-arm in today's standards. The PC quilter company had taken all the control pods and put their own stuff on it. Anyway, when I priced out how to get this thing up and running again, with the CNC, it was 10 grand. And I'm like, okay. The stitch regulator, which is basically, if you're going to run it manually, you need the needle to basically be sort of proportional to how fast you're moving it, so you get the same stitches per inch as best you can. Anyway, that was $1,000 for a stitch regulator. And there was no guarantee it was actually going to work, given that the control panel has been taken off this thing. So I said, well, we can do this. Let's get an Arduino board. I've never played with an Arduino board, but it can't be that hard, right? And let's see if we can make a stitch regulator. I ordered a stitch regulator that goes on a Husqvarna sewing machine, and Husqvarna uses pretty good encoder wheels. Some of the other ones are kind of plastic. These are actually metal. They're nice encoder wheels. So I ordered an Arduino board. I got the encoders, and I'm like, okay, let's get AI to help write the program, because I've never written I have no idea. I don't even know what it looks like, right? So got the Arduino, went into AI, and after about when I talk about pages, that's how many Microsoft Word pages that the conversation that I have with AI. So if I say I had a 120 page conversation, that means when I copied the conversation out of the and it's just Google AI. When I copied it out of Google AI, it put it into Word, it was 120 pages. So when I give a page reference, that's how long the conversation was when I stick it in Microsoft Word. Okay, so I put it in there, and it comes back, yep, this is a piece of cake. I said, can you give me a sample code of what this looks like? And it generated a code, and I basically had to do some digging and find out how many, a few details about the encoder wheels. And when it was all said and done, it gave me a 5-page code. And for those of you who don't know, it's in C++, as near as I can tell. Everything about this process was a learning experience for me. So I got a program, and I feel at this point, and this is, after all of my trials and tribulations with the original system and everything else, we're 4 weeks into this process by now. order the parts from Amazon, right? I get the Arduino card. I needed a digital potentiometer chip, so I actually ordered it from DigiKey. It was like $1.20. So at this point, I'm about, the eBay stitch regulator about $40 when shipping and everything. And I've got a $20 Arduino card. I don't even know if it was that much, but and then I've got a digital potentiometer. I really think it was $1.28 or something like that. Okay, I've got all my parts. I think I've got a pretty good program, right? I believe AI can write an Arduino program. This is a pretty simple system. It's just a resistive system. Basically, the quilting company, they didn't actually, this handy quilter's actually got it's got a control pod on the back of it, or a printed circuit board and a microprocessor. It's, relatively speaking, it's sophisticated. But the PC Quilter, the company that made all this mess, all they did was basically plug into the manual foot pedal port for this sewing machine. And the way that works, it sends out 5 volts and reads back the voltage. So it's zero resistance. Basically, when the foot pedal's all the way down, the machine's running wide open, right? Because you get 5 volts back through the leg. When the pedal's all the way up, you get, I don't know what it is. I'm going to just say infinite resistance, but I don't know. It's open circuit. The machine's not running. You push the pedal down a little bit. It was a 5K pot, so I'm assuming somewhere around 5,000 ohms. The machine starts running slow. So basically, I got a 5K digital potentiometer, and I know there's a lot of rambling, but we're getting to the point. We'll get there in a minute. So at this point, I've got the program, I've got my parts. I'm like, okay. So I download the Arduino IDE, which is basically the interface to allow you to upload programs to the Arduino card. I bring the program into the Arduino IDE, and I compile it, and it compiles, but down at the bottom it says, you're using 98% of the dynamic RAM in the Arduino card. That's probably not a good idea. So I go back to my Google AI, start a new conversation. Every time that I tell you that I went back to Google AI, it's a new conversation. Right, so that's number one point we're going to come back to. I should have said this right off the front. This is not this quilt machine. That's really not what this channel is about. But I watched a video, I don't know, 4 or 5 weeks ago. I don't remember when it was. And somebody made a video. They went to ChatGPT, they went to Google AI, they went to OpenAI, and they may have used somebody else too. I don't know. 3 or 4 AI programs. The point of the video, I believe, was that you need to get expert advice in tuning your car, computer tuning. And I may have this wrong, but I think he said, okay, I've got this car, I've got this engine, and he put in various specs, said, give me a VE table and volumetric efficiency table. Anyway, he did that with all the programs, and he uploaded the program in his tuning software. I don't remember what program he was using, but he uploaded each one of the versions, and a couple of them he said, I wasn't even going to run these because these things, these are not going to work. And I think the takeaway was you need to get expert opinion. You can't, AI, and the common term is it hallucinates or it lies to you. That's not really what it does. So that's point 2 we're going to talk about. Anyway, that video motivated me to talk about this one because I think this is a great example of how to use an AI program. So where were we at? I've got the program. It wrote the program based on all the specs I gave it. The encoder, the sewing machine, the resistance, diameters of lots of information, over 120 pages. Remember, this conversation was 120 pages. To the point, it actually stopped the conversation, said, I'm not talking to you anymore. And that limit's somewhere around 120 to 150 pages, because it happened to me multiple times during this whole process. Anyway, I load it up and compile it, and it says you're using 98% of your dynamic RAM. That's not going to work. So I go open up a new conversation. I go back in, and I said, hey, I have been having a conversation with you, and I gave it all the specs. You know, that's a handy quilter HQ16 with the encoders and everything I gave, effectively everything I had given it in the previous conversation, except condensed. And I said, you told me that, and I did use the word you. That's not it. That's not accurate, but you know, we're humans. That's how we talk. So I said, you told me I could use an Arduino card with this. But when I compiled it, it said that it was going to use 98% of the dynamic RAM. Are you sure this is going to work? And it came back, well, I was wrong. You need an Arduino Mega card. So 120 pages into this thing, and it never picked up that it was, it never picked up that we were talking about the Arduino, and I think Uno, right? I think that's the one I had. All right, so that's the, I think that's point 3, right? So 120 page conversation, and at no point did it go back and rethink what the problem was. So I ordered a Arduino Mega card, and again I had another conversation. And I should say that during this whole time, I like to keep multiple conversations going on at the same time, so that I can sort of bounce back and forth and make sure that my thought is I'm just trying to make sure it's heading down the right path. So I went back, had another long conversation with Google AI, and I said, hey, we got a Arduino Mega card, and here's the program. So this was a separate conversation from when I asked it about the 98%, right? So a new conversation. I said, hey, I've got an Arduino Mega card, and here's my program, and here's what I want to do with it. Can you identify any improvements that I could make with this program? And for those of you guys who are not familiar with Arduino, it's called a sketch in Arduino world. Not sure I know why. It's just a program. But it's called a sketch, just in case you want to know. And it goes through and says, well, your pin outs could be better, right, in terms of what you're connecting. It really, and I've had I forgot, I've got a display. I wanted to kind of, for testing, I wanted to read out thread inches per minute, stitches per minute, and then the X and Y coordinates. Don't need it while a machine's running, normal operation. I was just trying to, as a debugging. Anyway, it said, basically it said, your code looks okay, but you need to make these changes in wiring because that's not going to work. And in this case, it was actually focused on the little screen. It said, you've got the screen wired up wrong. Okay. So I went through that conversation and compiled the program, and just if you've played with AI and stuff like this, it will just give you what it, like in this case, can you improve the program? It gave me a line. You need to, think about changing this line to say this line to this. Basically, you come back and say, hey, can you give me the complete and updated program that includes all of your suggestions? And then it'll blow through and give you the whole program again. That's a whole lot simpler than trying to figure out, especially if you're not comfortable with the programming language. And C++ is not my bag. It's not my bag. So uploaded the program and put that in there, and the machine actually sort of worked. There was no way to stabilize it. Started another conversation with AI, uploaded the program that was working, said what we got going on, and said, well, it's probably noise. You've probably got electrical noise in your signal. You need to run a capacitor across your ground and 5-volt source. You need to run capacitor across your digital potentiometer, and you need to put some resistors across your display legs, because your display and your digital potentiometer are using the same digital ports, and they're not liking each other. We can talk about this all day, but in the end, AI decided that noise was my problem, and I think this conversation wound up to, it was 150, and at the end of the day, I still didn't have a sewing machine that was working. So I put that up for the day. Come back a couple of days later, and it started the whole process again. All right, so I've got a Arduino Mega card. Here's what I want to do. Here's the specs, and by this point, I've got everything measured, and I know I can be pretty concise in terms of what the components are by brand and by model, and what the specs are for everything. So I put that in here, and I say, here's the program I wrote. You notice I said I wrote. Anyway, it comes back and says, yeah, that you've got a good start, but your encoders are hooked up on they're not going to work. Basically, I have them set up in quadrature. Encoder wheels are a lot like a crank trigger, and with the crank wheel, crank trigger on a motor, right? It's a ring, it's got some notches in it, and you got a pickup that picks up either on the rising side or the falling side of the notch. Same thing on the encoder wheel. A little bit of difference on the encoder wheels is there are two outputs. You got your A output, which reads directly rising and falling, and you can choose one or both. And then on the B leg, it's offset by 90 degrees, 45 degrees, I don't know. And you can get that's all done electronically. You can get a rising and falling. So you can get 4 outputs every time on a 4-notch wheel, you can get 16 outputs on one rotation of the wheel. Quadrature. That's the term it's used. Okay, so the AI had set me up saying, for a sewing machine, you need to know position all the time. Backwards, forward, right, position. So it had set me up running quadrature. And during this last conversation, it came back and said, you got that pinned up wrong. So the program works, but I'm having all kinds of jumpiness. So AI sent me down a rabbit hole for probably 2 weeks of chasing electrical noise. I rewired it. I did a star ground pattern like we do on plasma torches, trying to get all the grounds together. You don't want to piggyback grounds. You want to ground from point A to ground, point B to the ground, right? You don't want to piggyback grounds. Okay, so I understand all that stuff. So I went down that pace. Nothing fixed it. It was not happy. Okay, so in the end it beat me, right? Okay, done. Come back later, start another conversation. And I said, hey, do I really need to know what position I'm in? Because in reality, all I need is that needle to move up and down based on how fast I'm moving on the hypotenuse, right? I've got an X encoder, I've got a Y encoder. All I really need to know is how fast I'm moving that resultant vector, right? That's all I need, right? I want the speed to change. I want the speed to change based on how fast I move it. It said, oh yeah, you don't need the quadrature. Okay. So I took off the B legs on both the encoders. So I had it write the code for just a leg on 2 encoders. And it was still giving me fits about the display. I said, just take the display out, right? If you think that's what the problem is, take the display out and give me a new code. So the code up to this point was 5 pages of code. Now it's down to like 3 pages. So it did make a difference. Put this thing in here and it still didn't work. Okay, I don't understand. Why is it not working? And the AI went right back to the noise. Well, it's got to be noise. So I chased that for a couple of days. Yeah, it wasn't noise. Finally, and at this point, I think I can safely say I am 500 pages into this conversation. And I saved all the conversations. So I'm pretty confident I got over 500 pages of conversation going on. Now, along the way, I've learned a lot about the Arduino. I've learned a lot about C programming. I mean, I've programmed in, yeah, I'm an old guy, right? I programmed in Pascal, I programmed in Fortran, I programmed in Visual Basic, but I just never migrated to C. Never needed it. Anyway, so I'm the syntax on C programming I'm getting kind of comfortable with. I'm not a programmer yet, but I'm getting there. So I started reading this code and kind of doing a little bit of research on the side in terms of trying to understand what the pins were. Arduino card has very defined input and output pins. And I'm looking at this, and it's got the AI has the X encoder plugged into I think it's pin 2, digital in and out, and it's got the other encoder on pin 4, which is not an in and out. So I moved the wire from 4 to 3, which is, near as I can tell, an in and out pin. And what do you know? The thing starts working. Still doesn't react well. So I'm 5 weeks into this. I think I'm about 5 weeks into this thing. I went from carrying this stuff out the back of the pickup and thinking I'm going to get it running to trying to build a stitch regulator that I thought was going to be pretty easy. I mean, in theory, it's a pretty simple device, right? Read 2 encoder wheels, tell me how fast they're going, do the Pythagorean theorem, literally just do the Pythagorean theorem, calculate the resultant velocity, and map that to a 0 to 5K resistor. It's not any more complicated than that. Okay, well, it's still not happy. So I go back to AI and I say, hey, you had this pin. I mean, you suggested that I put this wire on this pin. I moved it to this pin, and it seemed like it's working better. It's still not reacting like I'd like it to react, but it's working a lot better. I said, oh yeah, sorry for my mistake. That needs to go in that pin. Had the same type of issue on where it was sending a couple of wires from the digital pot. So it had those on I forget which pins they were. It's like, I don't remember what pins. It was up there in that single digit number, and it really wanted 51 and 52. I'm still a novice at this. Anyway, we got those moved around, and I'm like, okay. No, I'm sorry, no anything like that. It just like, oh yeah, that's not gonna work. That was a good decision on your part. So I'm like, okay. Well, I still need to figure out how to get this thing to work like I want it to work. And I start a new conversation. Again, I tell it what I've got, and I give it the latest and greatest program that works. At this point, I've got just the A-leg, not quadrature, no display screen. Basically, all I've got is that DigiKey digital potentiometer chip and Arduino board and 2 encoders. That's it. It says, well, you need to adjust your PID constants. And I'd been playing with them things for the last 5 weeks. I'm like, okay, what would be your suggestion? Still not happy, but it actually got worse. And I was like, okay, well, what do you think? It went back to noise. You knew it was going to go there, didn't you? It went back to noise. You've got noise on your wires. You got noise. And the reality of it is, I had a program from 3 weeks earlier that worked pretty well. My thought was, after all the conversations and the more I learned about the Arduino, it was probably the display screen, but it worked. There was a 2 or 3 second lag when I slowed down before the machine would stop, and a 2 or 3 second lag to speed back up. And I changed the I changed a lot of the constants in it. Went back and forth and back and forth, and it just seemed like that was the problem. The new program actually was, it had the display out and it was wired, and there were a number of wires that were changed. And I said, so basically I uploaded that program and uploaded the new program, and I said, this program actually works, there's just a lag. Your program doesn't work very well at all. Why? Why does this program not operate as well or better than this one? You know, keep in mind that we've got 2 or 3 weeks of optimization, theoretically, optimization going on in terms of getting better timing, taking out the display, which may have been causing issues, setting up the encoders to the right pins, supposedly. Anyway, it come back and said, well, there's no reason why this program shouldn't work. Hey, it's got to be noise on your wires. At this point, I'm 5 or 6 weeks into this, right? And well over 500 pages of conversation and multiple conversations. I may have lost my patience. You know, you treat AI as a human. It's not a human. It has no emotion one way or the other. Anyway, I said, I just told it, arg, this program works. Before any optimization, this program works, there's a delay in it. Where is the delay? Anyway, where is the delay? And eventually, it came back and said, well, your PID constants are too big. So I adjusted them. They're really small in this program. I got the proportional at like 0.002 or 3, no integral. No integral. I don't want, this thing does not like memory. So, and then on a differential, it's about the same, 0.002. So very small constants. And that's what it turned out. That's what it turned out to me. So, at this point, I have stitched feet of sewing. So let me summarize. First and foremost, you'll get the most out of AI if you have some knowledge of what you're asking. The more knowledge you have about the topic you're wanting to know about, the cleaner your conversation is going to be. Because, and this happened multiple times, and it's happened on car-related stuff multiple times. AI gets pigeonholed. The way it works, like I told you, I've had long conversations. It doesn't go back and review all of the conversation. It prioritizes the last question, significantly prioritizes the last question. You can tell it to go back and review the whole conversation, and that's probably the cleanest and safest way to do it. But the conversation, from my experience, the conversation stops sooner, right? If it goes back, so somewhere in the background, in my mind, Google is keeping track of how much memory that's being used. Normally, it just references the last question or the last back and forth you had, right? So right above your comment box, the last conversation, that it prioritizes that, and really doesn't give any consideration to anything that happened before that. If you tell it to go back and review everything, then it looks like to me that there is a capacity limit set in Google's, because the conversations stop sooner. And when I say they stop, they stop. The AI won't make any further comments on that conversation. It just stops. So you got to start up a new conversation, start all over. Because it does that, it can easily get sidetracked, especially if you make a random comment. You're going along, like in this case. You're going along, and I'm asking it about the proportional constants, right? The constants for the PID. If I bring up, if I just ask the question, would noise have an impact on what those constants are? It would get sidetracked immediately into electrical noise, and then go back through telling you how antenna effects and capacitance. If you don't know the topic, it's easy to let the AI loose, if you will. Because if you don't have a baseline knowledge, say no, that's not where I want to go. Let's go back and say, all right, staying focused on the constants. And this happened at various times throughout this whole conversation. So in my mind, perfect analogy of this is you got a cage with a bunch of cats, and you need to get the cats out of this cage into a cage that's, way over there. You open the door and you start herding the cats. Well, I don't know if you've ever tried to herd cats, but that's exactly what happens to AI. You end up, the cats go every which way, and you're chasing this one, and you're chasing this one, and you're doing your best to get to point B with all those cats. Yeah, nothing, it doesn't want to happen. AI does exactly that same thing. So having a baseline knowledge is the best way to minimize the amount of conversation and frustration you're going to have in discovering what you want to learn. That happened to make it car related. So I was trying to figure out how many teeth the crank wheel on the 4.6 mod motor for Ford had, and what its outside diameter was and what its inside diameter was. And this conversation turned out to be, I don't know, 40 or 50 pages. And I'm like, how hard can this be? It started out by giving me like 7 inches diameter. And I said, well, that can't be right. I mean, the place it has to fit behind the crank isn't that big. Are you sure? And you go, well, no. You're right. Right? It's only 5.35 or whatever it is. Same thing happened with the ID. I said, okay, what's the ID? Because I was trying to figure out, could I modify the LS crank wheel to fit on that 4.6? And it gave me a number of like, I don't know, 1.5 inches. I'm like, well, the crank snout is over 2 inches. That doesn't seem like that's the right answer. Then it gave me another number. It gave me like 3. I'm like, it's not that big. Anyway, that was a long conversation, but that's exactly the point I'm trying to make is if you don't have some baseline level of knowledge, AI is going to be a frustrating process. So you will get there. You just have to keep asking it questions. And in my case, remember I said earlier, I have multiple conversations. I usually have 2 or 3 conversations going on at the same time and try to ask questions from a different angle so that I can work my way through this. This was probably the most frustrating conversation I've ever had. The other one is, and this is in the news all the time, AI lies or it hallucinates. Hallucinates is the politically correct term, right? Not really. Large language models basically are probability models. They take all the reference material they have access to, right? And they say, based on this sequence of words, what is the most probable words or phrases that need to follow that, right? It's not checking facts. That is the key point on the large language models. I don't think anybody would argue with this. The large language models are not checking facts. It's almost like the better analogy is the best I can come up with is, in Galileo's time, everybody thought the world was flat. If there would have been an AI in Galileo's time, the AI would have told you the world was flat because the most probable answer to that question is that the world is flat. The other example, I'm just sitting here, I remember, and this was 3 or 4 years ago, some lawyers out of Brazil put together a response to federal court or, I don't know, Supreme Court, federal court, somewhere. And anyway, they had let AI write the response, or write the whatever it's called in law, write the document they send to the courts. And none of the references were actually real references. The case law didn't exist. The AI had made up all the case law. And I remember the conversation going on at the time is like, how can it get facts wrong? It's because it's not working with facts. It is working with probabilities. What is the most, given everything I have access to, is what is the most probable? So if it had a case with this number and a case with this number, and this, and it was, this one was about this and this was about this, well, the case that you're asking about kind of fits in between there, so let's make up some numbers. I don't know that I would say it's really lying. It truly is just trying to find the most probable answer to the question. Probably need to finish this up. First thing is having some baseline experience in the area you really want to know about is really important. The conversation you have with AI will not preferentially relook at the entire conversation. Now, I got a friend of mine, I'm not subscribed to ChatGPT. I got a friend of mine who is subscribed, and this isn't as much of a problem if you set the ChatGPT up as in projects, so it will use the information in the project, right, that you've got set up. But it still happens. It's a large language model. It's this whole phenomenon is still gonna be there. So a little bit of experience. It doesn't prioritize the entire conversation, and it doesn't hallucinate or lie. It uses probability to figure out what the best answer is. And just in closing, it's been interesting to me. I read a number of technical academic folks saying large language models are not the final answer. They may be leading us down a rabbit hole because they don't think. Large language models don't think. That's not the end game for AI. Well, in a sense, I would agree. I mean, you think of AI that it's always right. But if you're comparing it to humans, think about how humans come to a conclusion. They use all the information that they've gathered, and you and I both know not all that information is factual, but that all gets wallowed around. And so I would, I guess where I'm at today, I would hazard a guess that large language models are very close to human intelligence. What I would like to see in AI is it deal strictly in facts and being able to take those facts and synthesize a creative answer. And, you know, obviously there are humans that do that, but as a general rule, I think the large language model probably today fits closer to human intelligence as a whole than what we think of as the right answer to AI. And that's probably controversial, but that's where I'm at. Well, that's where I've been for the last 6 weeks. I think I wanted to get this done for my lovely bride for Christmas. Almost made it. Got a few parts coming in for the leader cloth and stuff like that, but the sewing machine seems to work, seems to sew. At this point, she's happy, I'm happy. We're gonna get back up on the truck. I've got, we're gonna start on the rockers, inner rockers on that 67. I hope you guys had a Merry Christmas, and hope 26 turns out to be a great year for you. Until next time, I'm Random at RandomRodShop, and I'm out of here.